Hi, this is Mark Kemper with EMS, and in today's video, we're going to look at 3D scanning for the packaging industry. And specifically, we're going to look at something called shadow boxes. Now, if you've ever been out on a shop floor, oftentimes you'll see either containers that have the foam or some kind of material with cutouts, and either tools or parts fit perfectly in those. And also in things like these, Pelican style type cases, they'll have cutouts. Now, a lot of that stuff is real basic 2D shapes, but some of the stuff gets pretty complicated, and that's where 3D scanning might help when you have more complex packaging that could maybe take advantage of 3D scanning. So we're going to get into that today. We're going to show you how 3D scanning may help bring some of this packaging into the digital age. So let's get started by actually taking a look inside this case, and what we have here is our API laser tracker. So this is the travel case we use for it, and we decided to use this because it's actually some pretty sophisticated packaging in here to hold this tracker and keep it from getting damaged, because we ship this thing around all the time. So if we open it up and take a look at it, you can see the tracker here, and when I take it out, what you'll notice is it's got quite a bit of shape to it. It's got curve here, it's got this shape, it's got this head right here, the laser head, that we don't want moving around. So it's not just a straight cutout, because we want to really cradle this in here. So we're going to get into kind of showing this in more detail and what this packaging looks like. And then also we have our V-probe head, which also has kind of a unique shape. Plus we've got some cutouts so we can reach in with our fingers and pull it out, okay? So we're going to show you how we're going to scan these objects so that we can help design some really good packaging to hold this, hold it. We want to hold this very tight. We don't want this head moving around. We don't want the body here turns back and forth. We don't want that moving around while we're traveling. And they don't lock into place, so we need to hold them snug. And same with the V-probe. We want to hold these in here really good. So we're going to show you how we're going to scan these objects and then go in and actually design the packaging for it. All right, so let's start by talking about what 3D scanner do we want to use for scanning something like this for packaging. Well, in the Creaform lineup, there's lots of choices. Everything from the Peel entry-level scanner to the HandyScan Silver series to the HandyScan Black series, and even the GoScan Spark. So all of them are good choices. Now, for this, I chose the HandyScan Silver series. That's the 307 and the 700. Reason being is it's laser-based, so that's going to work great on some of this stuff you may be packaging. Can be dark and shiny, and this is a laser-based scanner, so it's going to do a better job at it. But this is also a very affordable scanner. In the commercial world, this is a great value. Really good bang for the buck. Again, laser-based, really good accuracy, very portable and easy to use. So it's really a good choice, because we're not talking about metrology here. We don't need, super crazy accuracy. I mean, we're cutting out foam. So as long as we can capture this, relatively quickly and some good accuracy, that's all we need. So you could certainly spend more money if you want, or if you're doing other things that require that higher accuracy, you might look at the Black series. But honestly, this is a great choice for this application. Okay, so we're ready to get started with the scanning process. Now let me explain the setup we have here. So this scanner requires targets, positioning targets. That's the little dots you see here around the part in this case. And that's how it positions itself in space, and then it emits the lasers, and the lasers pick up the shape. Now, if you want to learn a lot more about the scanner, we've got some really good in-depth demos on all the scanners that we sell and use. And I'll put a link in the description below to this scanner, and you can go watch a really detailed demo. But explaining our setup here, I can either put the targets on the part, or I can put them around the part. Now, in this case, I'm just going to put them around, because we have all kinds of little fixtures and jigs and things we've built. And anytime I have something tall or skinny, I just pull this out. So I've got it on a rotary table. There's targets on the table. I've got these little triangles. Those help as well. And then just these vertical bars that have targets on them. So basically, I can scan this whole thing without actually putting targets on it. As long as I don't move the object in relation to the targets, we're fine. And I've also positioned this thing as it's going to be in the case, right? So I've got it exactly the way it's going to be stored in the case. for scanning. So let's go ahead and get started, and I'll explain some more. So first thing I'm going to do is I'm going to set the power of the laser, and I'll explain this in a minute. So we just go around and start scanning the part, and I've set the laser power a little bit lower to pick up some of this stuff, specifically the red plastic, okay? But you'll notice a lot of the black is not being picked up. I'm going to need more power on the lasers, but I want lower power to get some of this stuff because I don't want to oversaturate it, okay? And so I've gotten that, and now I can come in here and I'm going to crank the laser power up, okay? Now, in some of the higher end scanners that Creaform sells, they have a thing called HDR mode that automatically does this. It pulses 2 different laser powers. We've just got to manually do it, okay? Not a big deal. And again, this is a value-based scanner, and you can see now I'm picking up the dark and shiny. So it only takes me a minute to adjust that power. And I just go around, and I call it digital spray painting. We just keep moving up and down and pick up the shape. Now, you know, we're not doing reverse engineering of this part. We're not doing inspection. So I need to just get a good, you know, a good scan on it, but it's not critical I get every little thing. As long as I got most or all of the basic shape of this thing, you know, we'll be good to go, okay? So I just keep moving around it till I get, you know, exactly what I need, and then we can move on. So what I'm gonna do is just, you know, keep going around this thing till I feel I've got, you know, all the data I need. And then our next step, we'll go into some reverse engineering software, and we're gonna show you how to take this 3D scan data and actually design the foam for our case to hold this thing, you know, so it holds it really snug, it doesn't move around. So our next step will be to go ahead and scan the V-probe, which would be very similar to this, and then we're going to go into the reverse engineering software next. We're going to show you how to lay it out and actually do the design of the foam.
Okay, to get started now and actually designing it, what I did was I went ahead and actually 3D scanned the case itself, and we're going to kind of work backwards. I want to show the finished product here in the software, and then we'll work backwards. Normally you wouldn't have this because the idea is we're designing this. And we're going to use Geomagic Design X for this. I mean, there's plenty of reverse engineering software you can work with. So it really doesn't matter. We're going to use Design X for this exercise. Now, if you take a look, as we talked about, this packaging or this case is actually pretty complicated. You know, we've got these curved pieces up here on the top that hold the tracker in place. We have another curved one down here. We've got some curved pieces here that hold the head along with some pads. We've got these cutouts for the probe, batteries, power, etc. So you can get an idea of what, you know, this is a fairly involved design. Now, you'll also notice the layers here. Most foam is not a solid piece. It's usually done in layers of varying thickness. These layers are 2 inches thick, and they're glued together. Now, depending on the design, these could be all glued together first, and then this entire thing could be CNC machined out, or it could be done in separate layers and either laser or water jet cut, or they've got you know, different ways of cutting this stuff out, all driven by a CNC machine, whether it's a CNC milling type machine, a laser cutter, a wire cutter, or a water jet cutter. It just kind of depends. We'll talk more about that as we get into this, but that's pretty typical of the ways you would do it. But normally, you know, we wouldn't have this. We wouldn't scan the finished case because it doesn't exist. So we're going to show here how it's designed, but I wanted to just show the finished product first, and we just had the luxury of scanning it because it was already done. Okay, so the first real step in our process is going to be to import the scan data and basically get them in a coordinate system. I've already put them in a coordinate system. That's pretty straightforward. And then start to figure out the layout, okay? So we could, you know, take some manual measurements if we wanted, just to try to determine the size. But basically, we need to pick our case first. And, you know, there's lots of different cases, lots of different manufacturers. And typically, you're going to have a general idea of what case you might need, you know, based on the overall size and how many different components, you know, you're going to have in that case, and then how much cushion you want and things like that. Now, if you look at the scan data here, you know, the scan data looks pretty good, but it's, you know, we didn't get everything. It's not like we're going to reverse engineer these parts or do anything. We're really just going to cut some profiles through them. So, the scan data looks pretty good, but it's not imperative that you get every last detail because we're just using it for reference. So I have the tracker, and then I have the probe, the main body of the probe, and I've got them in here. And what I've already done is preloaded our foam. So once we've determined what size case, we already have the foam for that case already saved. So the scan data is up here. This is just polygon mesh, STL data. And then our foam is actually, solid model data. And you can see it's in those 2-inch layers. So each piece of the foam is a separate entity. And you can see it's got draft on it and the corners. And you can see in the bottom, in this case, it has wheels. So you need cutout for where the wheel well protrudes in. So this is the stock size foam. And then what we can do is we can go in and start to kind of lay out maybe where we want to put this stuff, as well as some other items that we're going to want in the case. So let me show you, for example. So we can come in and we can actually just transform the scan data around. And how I'm going to do that is just grab it, and I can play with moving it. Hey, could we fit it this way? No, that's too tight. No, so let's go ahead and set it back. Set this back to 0. And so we can play around with the positioning in the case, not only in the X and Y, but then also the Z, how far down we want it to go, things like that. So we can move this stuff around and get it, positionally where we want it. So let's say, hey, that looks pretty good right there. And then we'll go ahead and, decide where we want to put the probe. Let's say we think we want to put it in the middle, and maybe we want to orient it this way. And then what else we can do, let's move it up here a little bit. The other thing we can do is I have already created some of the more common items that probably don't really need to be 3D scanned, just really the outline. I took measurements of the batteries, the power supply, the extensions for the probe, and then we can do the same thing for those. We can let's grab these 3, and let's go back to that top view and decide, hey, let's slide those down there a little bit and, move them down into the box. Okay. So this is a neat way to move everything around. Okay, so to start the actual design for the cutouts, or for the machining or the wire cutting, we've got our stuff laid out. Now, again, I've loaded in the finished case, but I want to use it as kind of a design aid so you understand what we're doing. Again, normally this wouldn't be here. Normally what you would do is you would just start with the foam itself. So you would bring in the layers of foam. We've got it positioned where we want it, and then we'll start making our cutouts. But having the finished product here kind of helps us understand a few things. So let me explain. So you notice the foam doesn't follow the part, in this case the tracker body, the whole way. You see these cutouts here. Well, the reason being is this thing weighs like 20 pounds, and if you just had the cutout going exactly all the way around it, it would be very difficult to get it out. And you'll see for some things they design in like finger cutouts. Well, this thing is too big and heavy for finger cutouts. So we need to be able to wrap our hands around it and lift it up out. And that's why you see the reliefs here. But yet at the same time, let me hide the tracker body for a minute. We've also got this cradle down here and kind of this cradle in here. And if I turn the laser head off, we've got this cradle here. So we're going to actually have to design several profiles. So this is actually a little bit complicated, which is why we're using it and why showing the design in 3D is going to be helpful. So the first step, let's hide the foam for the case for a minute here. The first thing we're going to want to do is cut a cross section through this scan data. And to do that, let's turn on, we've got a plane created right at the top of the foam. Okay, so if we turn back on the phone for a minute, you'll see that. So that plane's right there at the top, okay? And we're going to want to cut what we call a mesh sketch. Now, we're not going to go into a ton of detail of Design X. We have some other great tutorials, but this should be pretty straightforward. So what we're going to do is cut this mesh sketch. We're going to cut it through the mesh data. And it's basically just a section through the data. So you can see here, I can slide up and down and pick the spot I want. Now, we're going to want the highest point. Almost think of like the parting line, right? We wouldn't want to cut that section up here because the tracker would never fit into the case. So we really want it right through the center. But I don't know where the center is. I can certainly guess and probably be close. But the other way I can do this is just using this guy right here and lifting it up. It's called the silhouette. And as long as that passes at least through halfway, which you can see I'm more than halfway through, it's going to find for us the highest point or the parting line, the farthest profile out. Let me try to get that right like that. All the way around this for us automatically. But you're going to notice it's going to put it at that top plane where I told it to cut the reference plane. So again, let's turn off the scan data and you can see that's going to be the highest point, and we're going to need that so that this thing can sit down in the foam. Now again, we're cheating, and so let's turn on for a minute the final product. And again, you can see how we're going to cut this. I'm going to use this as reference. So, but normally somebody who designs this stuff would figure this out, and that's the beauty of doing some of this here in 3D is having this. But again, you wouldn't normally have this foam, and of course I do. But so let's start up here. So we know we want to grip it well up here in the head area, and we want to grip it pretty well down here in this area. But we've got to leave room to reach in with our hands, reach around the tracker body and pull it out. So I'm going to just start building geometry because all this reference sketch is just reference. You can see it's just a bunch of points. It's not really real geometry. And when we go to machine this, whether we're going to laser cut it, hot wire cut it, water jet cut it, CNC machine it, or use an oscillating saw, we need a CNC toolpath. And those machines, which will convert it to basically a G code, they want lines, arcs, splines. That's really it. You don't want to just trace around with like multiple points like that. They don't like that. It's not good. Usually the machine will be jerky. You want nice straight lines, nice smooth tangent curves, etc. So we're going to fit real geometry through here. And, we don't have to be crazy accurate with this stuff. But we definitely want to be right on because we want a snug fit. This foam, there's different types of foam, different densities, open and closed cell. We're not going to get into all that, but this is going to be a pretty firm foam for this case because this thing is heavy and we don't want it moving around. So we're going to want a snug fit on our part. So let me fit these again. So I'm just windowing through an area, fitting a line. Okay, so I'm going to first go through and get all of the kind of straighter areas. So you'll notice I'm avoiding the fillets or the corners in here purposely right now. And again, I'm going to turn back on this, and just so I can see where I would normally put this, I'll fit a line through here. Let's start with that, and then we'll work our way down to the bottom, okay? So once I have those, now I'm going to add in my fillets, and it's nice to just round all the corners a little bit, depending on the foam, especially outside corners. It's nice to just round them slightly so you don't get it to kind of tear off. So now I'm just fitting curves in there. Okay. So we have that. And again, I'm going to bring this back on. And then, where do we go from there? Well, okay, let's draw a line here, here. We want to just touch that outside down to here. And I'm just gonna kind of draw it, and then we'll go back and clean it up. Okay, and let's turn off the foam for a minute here. So let's trim out. Actually, we'll radius most of these corners. I'll just put slight radiuses on some of these. So I'm just kind of moving the scan data around and getting it, the foam has some give, so it doesn't have to be absolutely perfect. Okay, so there is our first sketch. So let's go back and look at our case again. Pretty close to that. It doesn't have to be perfect here. So there's our first sketch. Now, let's go ahead and exit out. Okay, so let's bring the foam back. We'll bring back on our body, and let's bring the foam back for a minute. Okay, so depending on how we're going to manufacture this will determine what we do next. So for example, these are 2-inch layers. And like I said, if you're going to, let's say, water jet cut this or laser cut it, you're probably going to cut these, layers separately and then put it together. Okay. If you're going to CNC machine it and not cut all the way through the depth. So for example, maybe this profile is only going to go down halfway. We might glue all the foam together first, then CNC machine it. So it's going to depend. But let's assume for a minute, we're going to cut through the first 3 layers of these 2-inch layers of foam, and we're going to do it, let's say, water or laser cut. Well, we're essentially done at this point because now all we need to do is output this profile. And I realize we're missing a little piece there. So let's go back in. You can always edit your sketches. We want to make sure that sketch is completely closed. And we'll move that up, okay? And we can actually check that. And yes, everything is closed. Okay. So it wouldn't be the end of the world. It just wouldn't machine that area. So let's assume that profile is all we need and we're going to go cut 2 or 3 layers of foam. Well, all we got to do now is come in here and hit export, pick that layer, and export it because that's all the CNC machine would need, whether it's the wire cutter, the laser jet, the water jet, it doesn't matter. And you would typically output an IGES step, or what most of them use is a DXF file, and then they'll convert that to G code, for their actual programming. So we'll call this tracker body. I'll overwrite the old one. And there's our first profile. So that's all it would take to create that cutout. And that'll work on a lot of stuff, especially if you're just doing simple cuts. So we could do the same thing for the probe body here as well. Okay. But let's assume for a minute, let's go back and turn our foam on, that we're going to CNC machine this out because we're going to have multiple levels. We're going to be cutting out some pockets halfway down, etc. So then we might want to do something a little different. Okay. So now I'm going to come into the extrude command and I'm going to pick that. And we know our layers are 2-inch thick. And let's just say for a minute, we're going to run that down and let's turn back on our transparency. And let's go into a side view here. Okay. So, how far down are we going to go? Let's say, just for argument, we're going to go this far down because we're actually going to put a cradle or something under there. So we're halfway into that bottom foam. Okay. And I could see if we did do that, we would actually interfere with those wheel well housings. So that, that potentially couldn't work. So let's move it up. Just for demo purposes, I'm going to move it up to right here. Okay. And then the cutout is for this is the head here, the laser head that moves around. That cutout's only going to be down in this area. Okay. Because we can't do it there because we'd blow right through those wheel wells for the wheels on the case. Okay. And now I'm going to do it as a cut and you can see what it's done. Okay. So off for a minute. So you can see now we have the cutout, at least the main cutout. And then as we know, we're going to have to put some other stuff, that cradle and some other things in there. So now when we go to do our CNC machining, it's going to be much different. We're going to use probably a flat end mill and do a pocket milling routine and mill this whole area out. So that'll have several layers because you won't cut it all at one time. Okay. So hopefully that makes sense. So it's just going to depend. And you can also see this in a little more detail in this area here. If you notice where the probe goes, okay, you can see it's only 1 and about a half layer until you get to this kind of shelf. And then you can see we pocket out down another layer and a half. So that allows you to put a battery down in there and then put the probe head on top of it. So, it allows you to get creative with some of your, your packaging by doing this in 3D, and also by doing the milling versus, because the wire, if you're doing wire or usually laser or water jet, you're cutting through that whole layer. Well, you wouldn't be able to do that in these areas here. Okay. So there's our first pocket, and next we'll show doing some of the those curved pieces that are going to be basically going the other way. All right, so to design the kind of the curved cushion, we'll call it, here in the bottom, now we're going to need to take a section the other way. So let's bring our case back on for a minute, turn off the body. So we're talking about this piece right here, okay? So what we'll do is we're going to go ahead and do another, let's bring back our body, another mesh sketch. And to do that, we're going to go to sketch, mesh sketch. We'll pick that body again. And this time for our plane, we'll just use this, this plane right here. And we'll just bring it up into the main body. It doesn't matter where in this case, it's pretty much a cylinder. And then we're going to turn on the transparency of the body so we can kind of see where our foam is. And then we can start designing that cradle. So, we'll just come in here and I'm going to sketch. Let's do this. We'll do a 3-point arc, and or just for now, we'll trim it. We'll just eyeball it, put it right on there. And then we'll draw the outline. So here's the edge of our box that we built out to here. And, we'll decide how far up we want to go. Let's go right there. And let's make them both the same. Let me delete that one. Make it right here at that layer just to keep it, keep it simple. And then it's just a matter of trimming up all of this. So trim this, trim this, trim this, trim this, trim this, trim that. So that should give us a closed. So now we've got that one there. And, let's hide our, well, let's actually leave it so we can see how far we want to extrude it. Let's see what they did here. You can kind of see they went all the way out to here. So now we'll extrude, go to our model, and we will extrude this, and we'll go, looks like 2 inch. No, it's a little bit more than that. We'll make it 2.25. Okay. And we'll leave that as a separate piece because we're going to want to machine that out separately, so we won't merge it. Okay. So that gives us that piece there. So let's hide our case. And let's hide the body for a minute. So there's that piece there. Now, if we want to, let's see, did they extend it in? Yeah, they did. So we could extend it out here if we wanted to. Go back to our extrude and then just go the opposite direction if we want and go up to that face. I mean, it doesn't matter. Okay. So there's that cradle there. And it's the same process. So then we would design, let's bring this back on and hide the head for a minute. And you can certainly, let's hide this. Oops, hide all the foam. This one's a little more complicated, and we'll do the same thing. So it's just a series of cutting sections and building this. So, it's just now becomes a repetitive process. But if we turn that off, you can see what we have. And I'll go ahead and do that last one across this way, just so you get the idea. For time purposes, we'll go ahead and speed this up. It's the same process, defining your plane, cutting your section, creating your mesh sketch, and then just tracing over it and building real geometry of lines, arcs, splines like we did before, and just kind of tweaking it to get what we want for the next sketch. Okay, so here's that middle section, and for this one, we will extrude it because we cut it right in the middle. Let's bring back our our body here. So we'll extrude it out to 1 inch this way, and we'll go 1 inch the other way, and that'll give us the piece there in the middle. So you can see that. So that's the idea. We won't do everything because obviously it'll take some a little bit more time. But if we bring the lid on for a minute, we've got again some more cutouts we would add in there. And then, these are simple cutouts. Those would be wire cut or water jet cut separate. And this would be placed in there. So once it's all done, it will have all the cutouts in it and ready to go. But that just kind of shows you how you can use 3D scan data. And we're basically just using the scan data to, get everything in the case. Let's turn on kind of everything we did here. Everything in the case. Turn off the foam for a second. Okay. And then finally the probe head there. So, and you can see here for the probe, made some nice, again, reach out. So you can put your fingers, your hands in there. Basically put your thumb in there and the fingers in there, and you lift it up out. But we can lay everything out in the case in 3D, make sure it fits. And then we can, very quickly and accurately make the cutouts any way we want them. So we can follow it along like we did here, but then move away. So we've got an area to grab. And then, of course, add in those support foams underneath. But the idea here is to do it all in 3D. And then you basically start building up a digital library. So let's say the customer comes back and says, hey, this is great, but I want to add or put some different things in here. Here's a cutout for like power cords and other accessories. Maybe they come back and say, hey, I want to have 2 probe heads in here or something. Well, you've got it all scanned. You can pick a different case if you need to. You've got a lot of these components all designed in 3D. In fact, if these are common sizes, you don't even need, you can just import them in and put them in place if you even need to. But when you get to this complex stuff, it's really nice because you can lay it all out, not only in a 2D profile, which is kind of traditionally what they do, but 3D. And we noticed if we cut too deep, we were going to hit where the wheel wells for the wheels are. And, you may not see that till you go and cut all the foam and then realize, oh, this doesn't fit right. So, we can do it in 3D and look at everything and see how it's going to fit and make sure. So that wraps up just doing 3D scanning for packaging.
All right, so that wraps up this video on 3D scanning for packaging. And hopefully it was beneficial and you learned a little something today about how maybe for at least more complicated products, as something like this that has some real shape to it, 3D scanning might be a viable alternative, especially if you're going to use a CNC wire cutter, a CNC water jet, or CNC milling especially. You can basically scan the object, cut sections through it, or even build stuff in 3D, and then program your CNC machine, whatever it may be, to do this. And then you're also building up a digital library. As we mentioned, if a customer comes back and wants maybe, hey, I want that same case, but I want to be able to put 2 trackers in it, or 2 V-probes, or I'd like a little bit bigger case so I can put some other stuff in there, you could lay it all out digitally and then, go and machine it and pretty much know it's going to be right the first time. It's not guesswork, trying things that doesn't work and have to rework it. So the whole idea is to bring it into the digital age so you can do it faster, hopefully more accurately, better packaging, better layout, things like that. So this wraps up the video on 3D scanning for packaging.